Acid-base balance. We're going to go through some tools, some disturbances, and how the body compensates for them. Here, the first tool we're going to use is the acid-base box. Acid-base boxes are a nice, simple way to look at a disorder. Now, disorders are going to be things like acidoses and alkaloses. These are the conditions that you'll get to have an acidosis or an alkalosis. So you might have a respiratory acidosis, or a metabolic acidosis, or a respiratory alkalosis, or a respiratory acidosis. Those osis portions are the condition that is involved. If we want to look at blood pH, we call it an emia. So you could have an acidemia or an alkalemia. For a metabolic component, we're only really looking at bicarb levels. We have the edges of the box at 22 millimole and 28 millimole, although 24 to 25 millimole is what we would normally see. We give it a little bit of a range. Our respiratory component is PaCO2, which is the partial pressure of arterial carbon dioxide. Here we have to do something pretty crazy, and we have to flip around our lefts to rights to make this work out. We're going to have 48 PaCO2 and 32 PaCO2. If we want to use our first example, so let's just go through one of these just to go through the naming process of which condition might be involved. If we did an arterial blood gas measurement and we got a pH of 7.62, that would give us a blue gnome outside the box. A bicarb of 18 gives us a red gnome outside the box on the acidosis side. And finally, a CO2 value of 18 gives us a blue gnome on the alkalosis side. This is the beauty of an acid-base box because we can name this disorder. If they had this arterial blood gas, you could look at the acid-base box and say, respiratory alkalosis. Why? Because there are two gnomes on one side. That's how the naming goes. Respiratory alkalosis. You might ask, well, what do you do with that gnome on the opposite side? He was an acidic gnome. Why is he out there on the bicarb side? Well, it just so happens that the body is trying to compensate for the respiratory alkalosis. So if we were going to name that, it would be a respiratory alkalosis with metabolic compensation. That naming process all works with these simple acid-base boxes. I know right now you're going, what is he talking about? Let's go through another example. Let's say we have a pH of 7.59 obtained through an arterial blood gas. Blue gnome outside the box. We get a bicarb value now of 24. So now we're going to throw a green gnome inside the box. Why is he inside the box? Because you're going from 25 to 22, you're somewhere within that range. If you're below 22, you'd be outside the box. He's in the box because he's within the 22 to 25 range. Finally, PCO2, 26 millimeters of mercury. That's another blue gnome outside the box. So of course, we can name this. We can name this disorder. It is a respiratory alkalosis without metabolic compensation. Why do I know that? Two gnomes on the same side, outside the box. That's how the naming works. Why did I know there was not a lot of metabolic compensation? Because if the body was trying to compensate, they would have put the gnome outside the box. If the gnome is in the box, no compensation yet. Outside the box would have got some compensation.